So I'm very happy to see so many people here. 12 people so far, 13 people, and there will be more people coming today. And I would like to welcome you very much to the Pencil Code meeting 2008, which we will hold here at the Leiden Observatory. And of course we are very happy with our sponsors, the European Science Foundation and the LKBF, who are paying for lunch and for some travel costs. So I would just like to give a brief introduction to what is the Pencil Code meeting and why do we have Pencil Code meetings, and then I will also give some practical information about the form of the meeting and the infrastructure both here at the university. So the Pencil Code meeting, I like this quote from the webpage, which I think I took from one of Axel's files. Actually, I changed a little bit. The Pencil Code meeting is an annual meeting dedicated to the Pencil Code. The purpose of the meeting is to bring regular users and core developers together to discuss scientific and technical progress since the last meeting, to instigate collaborative projects, and to allow new users to learn more about the code and to interact with other users and developers. And this was something that we did for the first time back in 2005 in Copenhagen, and again in 2006 in Copenhagen at Nordica. And then we did also Nordica in Stockholm in 2007. And you notice here that the number of participants has risen quite sharply. I remember very clearly this time in Copenhagen when we were, I think 5, maybe I have to be wrong, I think maybe we were only 4. But I remember clearly giving a talk in front of 3 people. That was Axel and Toby and Tony. And Axel was taking a nap and Toby and Tony were programming. And that was a very interesting kind of atmosphere. But of course that changed completely, I would say, mostly with Stockholm last year, where suddenly there were 19 people. And that of course makes everything more organized. You meet more people, you interact with more people, and I think it's much nicer that we are so many people now. And it's nice that we are not only the core developers, but there are many people who are new to the code or who have used the code just a little bit. So what is it about this Pencil Code? Well, you can write out some facts about the Pencil Code. I've done that here. Of course, we all know it was originally designed by Axel Wolfgang back in 2001 based on ideas that go even further back. I'm sure they can tell us anecdotes. And it was originally designed to handle problems related to MSD turbulence and dynamo action. It's a 6th order spatial derivative, 3rd order in time, symmetric finite difference code. It's designed to be cache and memory efficient. That's very important. It's designed to be a good parallel code. The first CVS version appeared in November 2001. You can actually download the code to November 2001 and look at the files there when initial conditions actually appear in the start.f90 file. Oh yeah, of course they don't anymore. Today we have 73 modules. About 30 of them are physics modules. Of course they all come with maybe 3 or 4 different flavors. So there are many modules now. And there's 150,000 lines of code, and actually just from last year it's up from 120,000 lines of code. The code is really growing rapidly. But I would claim that this was just the facts. I would claim that there are some Pencil Code values that are maybe even more important than these facts about the Pencil Code. And I think one important Pencil Code value is that the Pencil Code is very versatile. It's easy to adapt. It's easy to put in new physics. It's easy to put in new terms. It's easy to put in new dynamical variables. I think that's a very important Pencil Code value. Then another Pencil Code value is that there's an active community that gives support and feedback to new developments, so that everything is discussed. There's a quality control. If someone does a change to the code, there's a quality control by the community that says, is this a good change, is this a bad change, what can be done to make that better, does this fit in with the rest of the structure of the Pencil Code? And that brings me to my last value of the Pencil Code. There's only one version of the code. I think this is extremely important, and it brings me to my point about why we are here. And it is because there's only one version of the code. It's very important that we all talk together, that we agree on what is good to do with the code, what is bad to do with the code. How do you go about implementing new things for your special purposes that, to a first order approximation, doesn't bother anyone else, and maybe even better, actually benefits anyone else. Yeah. So I think that for me these are 3 very important Pencil Code values. So that really brings me to why do we have an annual Pencil Code meeting? Well, the way I see it is that we are going to review changes that were made to the code during the last year. These can be new physics modules, they can be changes to how we do things, it can be technical, it can be scientific. Then something interesting, we teach users new techniques and methods, and this is something that we will see a lot today, where we will learn both about how to change from one version control system to another version control system, and then we will learn how to use Python instead of RDL. So maybe we can get rid of our total addiction to RDL, which is hard coded into the pencil code right now. I think this is very important also. And I think this is important. We plan a roadmap of future changes to the code. We decide what do we want to have changes during this next year, and who will do it, and how will we do it, and what are the timescales. Yeah. And yeah, as I said before, it's important that the regular users come and meet the core developers, and that we can interact, and that we can talk together both about scientific things and about technical things like how to program new things in the pencil code. Then also important is the scientific result. The pencil code was always driven by science. None of us here are full-time programmers, except for maybe Wolfgang now. But none of us are full-time programmers for the pencil code. We all have programmed the pencil code in order to make scientific papers. So I think it's important that we also discuss scientific results, and that we show each other, well, this code can actually be used for something. We have a good publication. And then, of course, at some point, I think it's great to have you all here. I think we can learn a lot from each other. I think we can also talk a lot to each other and just enjoy being around people who are interested in the same thing as we are. So I think this is one of the important things, get to know each other. So just to show again the growth of the pencil code, this is some plots that Axel provided me with. This is, as a function of time in years, the number of auto tests. So for those of you who don't know, there is, in order to validate that the code does not have any error in anywhere, every night there's a nightly test being done where a number of test problems are being solved by the pencil code. This is compared to what we believe the results should be, or rather what the pencil code used to think that the results should be. And if those two results don't match, either someone put a bug into the code or someone improved the code, then you have to decide should you clean the bug or should you update this test problem. And this is something that started, apparently around 2003 with just a few test problems. And actually you can see that there's a linear growth of the number of test problems, and we're now up to 30 problems. Which means I think even on a good PC, if you run this, it would take, what, 2 hours? 1 hour? 2 hours. So this is something that, so actually was of course pointing out that is still, even if we worried about having 100 auto tests, that would probably take another 10 years before we come to 100 auto tests. But of course it's something to think about, that there are now so many physics modules there, they all have to be tested. And in the beginning you could run the auto test in like 15 minutes probably, but it takes longer and longer time. And that's one reason why it's important that we meet here. This is also fun. This is again from the time. The black line shows the number of subroutines. The number of subroutines, right, Axel? Yes. So you were grabbing for subroutine. Okay. The black line shows the number of subroutines from the time. So you can see this has been growing steadily up to more than 200 now, and the red line shows the number of lines of code, and you can see that it's just been growing, and peaking now at like 150,000 lines of code. And as I was saying earlier, last time we had a meeting, that was here, and since then the code actually grew from 120,000 lines of code to 150,000 lines of code. So it's really still growing a lot. Yeah.
And our routines are getting longer and longer. And our subroutines are getting longer and longer.
That's exactly the point, yeah, because the number of subroutines is actually not growing as quickly as the number of lines of code. That's true.
And is that bad or bad or good? I think it could mostly be considered bad.
I think it's good if it's very general code that you are putting into the source, but it could be very specific for specific problems that everyone is compiling. Everyone has to compile because I put in some kind of stupid term that I only use once with an if logical that is always false. Then it's bad, right?
It's maybe all comments.
Sorry?
It's maybe all comments.
That's true, man. That is very good. Then I support it fully. So this was kind of the first part of my introduction talk, just about some motivation for why do we have pencil code meetings. So now I'm coming to where we are. We are now at Leiden University, and actually this is the oldest university in the Netherlands. So very important. It was founded back in 1575 by Prince William of Orange, who was of course the founder of the Dutch royal line. And there's a very funny story to that. There was a terrible civil war in Holland back in the 16th century because Holland was a part of Spain, and Spain were Catholics and they didn't accept that the Dutch had become Protestants. So there was a very, very terrible war that lasted 100 years. That was called the 100-year War. And at one point, the Spanish were laying a siege on Leiden because they wanted to occupy Leiden, and the people in Leiden refused to give up. And eventually, what they did was that they cut the dikes, so there was so much water coming in, and the Spanish drowned. And this was this guy, Prince William, was of course very happy with that. He was the leader of the Dutch, so. When he heard that the Leiden had defeated the Spanish, he said, okay, you can have a president, you can either become a tax-free city or you can get a university. And I think today, if you ask any given city on the planet if they would rather be tax-free or have a university, they would choose for tax-freedom. But I think they were very smart back then because they knew that if someone tells you that you're tax-free, it only lasts until the next king comes, right? So the good people at Leiden chose to get a university. And I think this is a very excellent choice because you can just look at this list of famous professors from Leiden. So there's Willibrord Snellius, known for Snell's law. He was the founder of the Leiden Observatory, which is from 1633. Anders, Hertzsprung, Lorenz, Seemann, Albert Einstein was an external professor here for 10 years. He often gave lectures here. Ehrenfest, Ord, Wilhelm Sitter, you can mention many others. There's really a huge amount of famous physicists and famous astrophysicists who work here in Leiden. So the old observatory, the Stermark, was originally built in the city center in 1633. Of course, you can't do astronomical science there anymore, but there is a beautiful old observatory in the city center, which I would encourage you to go and look at if you go for a walk in there. And today, Leiden Observatory, which is now here, and the new observatory, has approximately 20 faculty, 40 postdocs, 50 PhD students, so it's one of the really big astrophysical institutes here in Europe. I put in some nice pictures of Leiden, so I hope this will encourage you to look around a little bit. Lovely windmills, lots of history, nice canals, beautiful houses, Spanish who panic because they're drowning. And actually, this is celebrated once per year in October, so then all of Leiden goes completely berserk. And there's a rule that everyone who lives within the canals get a free herring. It's kind of a crazy thing. So I think it's a very lively city with a lot of tradition. So that was just about Leiden. I just wanted to come back to our meeting. There are some highlights. Today we will hear about changing from CVS to SVN, post-processing with Python, and the other days there will be excellent talks, hopefully, about chemistry modules and particle population and large-scale dynamos and lots of discussion. Which is bringing me to the form of the meeting. So the way I planned this was there would be mainly scientific talks in the morning session, and one reason for that is that that people from the observatory might want to look in on some of the scientific talks. They will not benefit anything from our discussions. So I tried to have the scientific talks in the morning, and I told the people at the observatory that they're welcome. I sent to the programmers that they're welcome to come and listen to the talks in the morning. So we have to be a bit on schedule in the mornings, depending. We can quickly see if there's anyone who is not one of us here, right? So I've given 45 minutes per talk. That might be a little bit much. So first of all, you get lots of time for discussion. And if someone ends, after 15 minutes and no one has any comment to that, I think we can just do all kinds of other work. We can start on a discussion topic, or we can just spontaneously talk, or people, yeah. So I think don't be too bothered with the 45 minutes. If you can't talk for 45 minutes, absolutely fine. But I think the talk should start relatively on time. It doesn't matter if they end half an hour earlier. So after lunch, there's mostly discussion sessions. And of course, these are meant to be very informal, but still there is a little list of topics on the website. And I believe that I printed out the program. It's lying around somewhere. There is a list of topics, and if you want to add some topics to that, maybe the best thing is really to tell me, and then I will put them on the website. And each session should have a chairperson. We'll find out about that, someone leading the discussion. And I think it's important that we take notes. If this has to be sustainable in any way, there's no point in us deciding everything in the world if we can't remember 2 weeks from now. So we have to find out some way of taking electronic notes. Because we just for each session we find out who is actually writing the notes, and then we just add it to the CVS repository, and then the next person can CVS off that file and then continue with that file. Then there's something new which I like a lot, is the tutorials which I put today, is the changing from CVS to SVN and the post-processing with Python. And then on Thursday, I would actually like, there are some new users, so I dedicate a couple of hours to having a question session where the new users can ask questions, present what their proposed projects are, talk of, maybe just quickly mention what they want to do, and then we can comment. Say, okay, it's a good idea, it's a bad idea, you should do this, what you do, you should do that way. But I will come to people individually and ask, and then later on I will say how we will do this exactly. I'm not so sure yet. But there are some new users here, and I think it would be great to hear about what their projects, what their potential projects would be. So food, lunch and coffee breaks is paid by our sponsors, which anyone who has tried to eat in the cafeteria will actually appreciate. So we will get 2 coffee breaks per day. That's actually supplied by the cafeteria. Now we already know that they can't even make coffee anymore.
Bad cups.
Bad cups, okay. But lunch comes from a sandwich catering place, so it will be delivered here at around 11 every day, just some sandwiches, and then we can have the lunch up here. So there'll be a long lunch break, and I'll just put the sandwiches in a big pile. And then, it's actually funny, the sandwich catering place is called Het Beleg van Leiden, and Beleg normally refers to the siege of Leiden, the famous historical event, but Beleg also means meat cold cuts. So it's a pun, in case you were wondering. And for lunch, the only thing that's not served is anything to drink. I bought a lot of mineral water. If anyone is happy with that, that's fine. If you want Coke or iced tea or anything, you can go down to the ground floor and there are snack machines where you can buy whatever you want. And they also serve food from around 12. And the snack machine is down there, take coins, euros, of course. So that should be fine. And then Wednesday, we'll have kind of a conference dinner. It's not supposed to be really a conference dinner. It's just that we all go out, and then I suggest we go for some Indonesian food, which is a very traditional thing in Holland. And there's an excellent restaurant where I will order a table from, so for Wednesday at 7 o'clock. But I guess we'll talk more about that tomorrow. You all know about this wireless internet because we wrote it there, so that should be fine. Just coming to my last slide, actually, that there's one important thing: you can't leave the building after 6 o'clock. They lock the doors. But what happens is that I have a key, Vlad has a key, and I actually got a key for Wolfgang and Toby also. They just don't know yet, but you will also get a key. And then if you want to stay here longer than 6 o'clock, you have to make sure that any one of us is still here, because really you can't leave the building without a key. And these keys, these electronic keys, are not for the main glass door. It's actually for the little door just around the corner at the direction of the bicycle sheds. But that is the thing. If you are stuck here and you don't know anyone who has a key, obviously you just go around to an office and find someone who has a key. I'm sure someone here is working longer, and I guess we had success with that a couple of times, right? So that should work. And what kind of
could find people here on Sunday at 2 a.m. actually.
Okay. That's good. So Wolfgang and Toby, I will give you a key soon. And that's actually what I had to say, but I would suggest one thing which I know Vlad hates, and that is that we all, one at a time, just get up from the chair, say what our name is and what our interest with the principal is, just 10 seconds. So maybe we will start with you, Axel.
10 seconds?
Yeah, maybe 15 seconds.
So I'm Axel Brandenburg, and started this thing with Wolfgang. The connection was, of course, the course on supercomputing that we were teaching back then. So I'm mostly interested in dynamo theory, solar dynamo in particular, with additional applications or with additional interest in astrobiology. And I'm working at Nordita, which is in Sweden now. It moved 2 years ago from Copenhagen. And that's a place where there is research in all different fields of theoretical physics, including astrophysics. And in the 5 years to come, there will be a very enhanced effort in dynamo theory, because I got a big grant from the European Union. So there will be some 8 people working on dynamo theory in Stockholm as of soon. with anybody's interest, please watch out for advertisements of positions that will perhaps come by at least October or something, and the ground principles should start in January. Okay.
My name is Tobias Heinemann. I've started using the pencil code a couple of years ago when I got to know Axel in Copenhagen. Today I'm doing a PhD in Cambridge and I'm still using the pencil code. And I'm working on accretionless turbulence.
Transport.
Some transport.
Transport.
Hi, I am anders1. I'm working in Mary College London, and my interest is turbulence, energy, and maybe polymetric flows with pencil. Do you see that?
I'm Indiana Sundberg. I was sociologist. I was here in Stockholm last year as well. So I already, those of you who don't know me, I'm doing a sociological study on the use of numerical models in different kinds of scientific disciplines. So astrophysics is one of them, and yeah, so I'm going to tell a little bit about what you do.
I'm Patrick Kepler. I work in Helsinki University as a postdoc, and I'm mostly interested in dynamo theory and turbulence, convection, stuff like that. And I've been using Pentacle for a couple of years now. Although I was in the meeting where this code was started with Fuba 7 years ago, but there's a gap of a few years when I didn't use it. And then I was in Stockholm as a postdoc for a while, and Axel has invited me again. So what I will be giving a talk about latest convection simulations on Friday.
I'm Graham Sarson from Newcastle University in England, and I started using Pentacle a few years ago to do G-dynamo simulations, just spherical shell convection in a Cartesian box. And I've sort of been doing other things mostly for the last couple of years, and been letting that sit in the back burner. So I'm here just to see what's new with the code and try and get back into it.
And what we first I'm Martin Gruber. I was one of the people who started the code. I left academic science by now, but by inertia and so launched the code, trying to get some stuff implemented. Mostly, what I'm going to talk about on Friday is something that I wanted to do for a long time, and now that I don't do anything scientific with the code, during the time that I spend on the code, I can find something.
Hello, my name is anders1. I'm working, I think, since 2006. I'm a former postdoc of Axel, and actually I'm working on convection in both on standing box simulation, and also on the kata mechanism, excitation of wave with a PhD student.
My name is Frank Dettelbier. I'm from the Planck Institute for Astronomy at Heidelberg. I'm doing a PhD, started about 1 year ago to work with pencil code in order to simulate dust particles in turbulent protopenetrators.
My name is anders1. I'm also from the MPA in Heidelberg. I haven't used the pencil code yet, so I'm a newcomer. I'm working on coagulation and fragmentation of dust particles, and I gave a talk on Thursday about the Monte Carlo code, which I think it would be a good idea to build into the pencil code.
I'm anders1. I'm also from the MPA in Heidelberg, and I'm also working on dust particles and protoplanetary disks, especially with I'm concerned with the relative velocity factors.
I'm Martin Tokuka, and also working very much with pencil here from the rest that I was
message for Michael from Pencil that we should work together. And I work on some more proposals jets that actually drive moving turtles.
I am Vladimir Lyra, and I started with advanced coding in 2005 for my PhD, which is basically a planet formation models. So, which I'm supposed to mention.
And my name is Anders1, and I am interested. I started the Pensacola in 2003 at Nordica, and I'm interested in the notion of solid particles in gas turbulence, and also the instabilities related to the motion of solid particles, and also generally in magnetic fields and dynamic theory. So that's what I had to say. So what will happen now is the first point of the program is that Axel and Toby will tell us how to change from CVS to SVN. And I hope they will also start just briefly explaining what even those two things are. Just 1 minute bit.
Right, yes. I feel a little bad that I haven't prepared anything. I can try.
But everything is ready for the switch, right?
Almost. In half an hour. No, but in principle it should work now.
What's this from? You need to compare?
I don't know whether I can connect to the.
Oh. That is not up yet.